Okay, so we'll now move on to solving worksheet problems related to disk files and buffers. For exam prep section 1, we specifically focus on questions 3 and 5. So I'll be going through these question 3 and question 5. So if you wanted to attempt them on your own, you should do so now and then come back to this video. Okay, let's first go over question 3. So question 3a asks, or it proposes a schema, a table for cats with caller ID, age, name, and color. And one thing to notice is that name and color are both varchars, meaning they are variable length records. 3a asks, as the records are variable length, we will need a record header in the record. How big is the record header? You may assume pointers are 4 bytes long and that the record header only contains pointers. So my approach to this question first would be to kind of draw out what a example record would look like for this table cats. So here's a good estimate of what that might look like. So recall for variable length, the fixed length records first, records after, so after caller ID and age. For each variable length record, we need one pointer in the header record or in the header of the record, and each pointer takes up 4 bytes. So since there are 2 variable length records, we should have 8 bytes total. And here's the math behind it. Okay. So we'll now move to question 3b. 3b asks, including the record header, what is the smallest possible record size in bytes in this schema? So the smallest possible record is the case where our variable length records, their lengths are set to 0. So name and color might be kind of null, or maybe not null, but like empty strings. In this case, the record will end up not looking like this, but rather both pointers will just look like this because name and color will take up no space. So our answer from part 8, color ID is an integer, so that'll take an age, it will also take 4 bytes. So in total, we'll have a 16 byte record as our smallest possible case. Great. We'll now move on to 3c, including the record header, what is the largest possible record size in bytes for this schema? So here is just the opposite. You can just take the answer from part B, that was the minimum case, and then we add the maximum case for each variable length record. So for name, the maximum case would be when name takes up 20 bytes, and for color, the maximum case is when it takes up 10 bytes. So you take the answer from part B, 16, you add 20 for name and 10 for color. In the end, you get 46 bytes. Okay, let's go over question 3D. So 3D asks, suppose we are storing these records using a slotted page layout with variable length records. The page footer contains an integer storing the record count and a pointer to free space, as well as a slot directory storing for each record a pointer and length. What is the maximum number of records we can fit on an 8 kilobyte page? So let's see how we would approach this problem. So for the maximum number of records, we should strive to fill the page with minimum length records. And from part B, the minimum length of a record is 16 bytes. So each record takes 16 bytes. Each record also takes 8 bytes in the footer. So 16 byte record plus 8 bytes of metadata in the footer. What is this metadata? This 8 bytes is 4 bytes for a pointer to free space. And the other 4 bytes is a length of the record. So the total amount of space that a minimum sized record takes is 24 bytes per record. And we'll see why this value is useful in a second. So now let's kind of start solving this problem. First, we want to compute how much free space do we have solely for records. So we are given that a page is 8 kilobytes, and 8 kilobytes for one page, that should be 8,000.
1 kilobyte is equal to 1024 bytes. Okay, and then we are going to want to subtract 8 bytes. Why do we subtract 8 bytes? Well, we have some footer metadata. We have 4 bytes that is a pointer to free space. And we have another 4 bytes, which is the record count. So we subtract this, and as a result, we get 8,184 bytes of free space for records. Okay, so that's kind of step 1. So this is how much free space we have specifically for records. Step 2 is now to, with this free space for records, using the minimum length records, how many minimum length records can we store in this page? So we have 8,184 bytes of free space for one page. And we know that each record, one minimum length record will take 24 bytes. As a result, you get a total of 8,184 bytes over 24 records per page. So you can see like why I'm formatting it like this, that we can kind of cancel out units. So these cancel out, so we get records per page. And I kind of did the same thing here, which is why I got this value in terms of bytes. And this equals to 341 records per page. Okay, great. Next question is 3E. Suppose we stored the maximum number of records on a page and then deleted one record. Now we want to insert another record. Are we guaranteed to be able to do this? Explain why or why not. So recall in 3D, the assumption we made was that we were storing minimum length records, and the minimum length from 3B was 16 bytes. Well, what if we kind of, inserted another record after that, and this was a maximum length record of 46 bytes? Then it wouldn't fit. So the answer to this question is no. We deleted a 16-byte record, but record can be, like the next record that we insert can be up to 46 bytes. Question 3F. Now suppose we deleted 3 records. Without organizing any of the records on the page, we would like to insert another record. Are we guaranteed to be able to do this? Why or why not? Recall here, we delete 3 records, but these 3 records are not guaranteed to be contiguous. So the answer is no. There are 48 free bytes, but they might be fragmented. There might not be 46 contiguous bytes where we can insert, a worst case 46 bytes and it will all fit because of fragmentation. Okay, that's all for question 3.